folks, and welcome to this lesson on alloys. By the end of this lesson, you should be able to describe an alloy and explain the properties of alloys. Now, alloys are something that you probably use a lot in your day-to-day life that you may or may not think about, depending on the type of person that you have. An alloy is basically a mixture between a metal and another metal or a non-metal. Some very common examples of alloys that you see in real life are in things like stainless steel. That's an alloy between iron and carbon, and usually a few other things as well. You also have things like bronze, which is primarily copper and tin, though it can also have a few other things, and brass, which is copper and zinc, with a possibility of a few other things. Another common alloy that you might encounter is gold, where you can find jewelry that are 24 karat, which means it's just gold. And then you have a different variety. Usually they can go down to about 10 karat, so it would be a proportion of 10 to 14, gold to something else. Now, what's the point of using alloys? Well, one reason a person might use alloy is you are not able to afford some of the metals that you want to use. Something like copper, especially pure copper, is going to be pretty darn expensive, so if you don't have to have pure copper for something else, for whatever you want to do, it's a little bit useful and going to be better on your pocket to mix it with something else. That being said, that's not the only reason a person might decide to use an alloy over something else. Alloys can also have different properties from the original metals that you have. Now, these properties will change quite a bit. One of the big things that it's going to change is that non-directional bonding aspect of the original metal. And how much of a change you get is also going to depend on the proportions that you have. So if we're looking at the non-directional bonding aspect of metals or pure metals versus alloys, if you take your pure metal, remember that because of non-directional bonding, when you apply a force to a metal, those cations can slide against each other, and so instead of breaking, you just have it shifting to give you something that can be malleable and flattened or ductile. Now, this can change a little bit once you start adding something else. Because of the fact that your something else is going to have a different size, different charge, might not actually be capable of participating in that metallic bonding side of things. In the case of something like a nonmetal, it can disrupt that structure that you can get, which means that when you apply a force, the presence of different atoms might mean you're not going to be able to shift things very smoothly. That sliding effect of those cations when you apply force, it can be changed or not really be able to happen at all around that particular other substance. Now, this can be useful. If you want something that is stronger, something where if you put a little bit of force onto it, it's not going to bend, then it can be useful to have something else in there to make sure that it doesn't bend. That's one of the reasons why when you see a lot of gold jewelry, it's not going to be 24 karat because that gold is so malleable. It can, like small bits of force are going to put in dents or warp the whole piece of jewelry. So you see a lot more alloys because it gives it a little bit more strength. The same thing goes with steel. Iron is great, but if you do want a little bit more strength, you toss a little bit of carbon in there, and that's great. Now, if you put too much carbon in your steel, though, this is going to change that metallic bonding structure so much that, yes, it is going to be strong, but it becomes brittle. So if you put in too much of the other thing, you can get to a point where you don't get that malleability as much anymore. Now you get something that is going to break, like an ionic compound and so on and so forth. Other ways that making an alloy can help is it can be more resistant to corrosion, it can enhance magnetic properties, it can increase ductility, and so on and so forth. And that's the end of this lesson. I'll see you next time.